In this video, we will be seeing about feedback amplifiers and in which we are going to attain the course outcome of how to analyze the four types of feedback amplifiers. We are going to now discuss in detail about the structure of feedback amplifier and the properties of negative feedback. Now, let us get into the topic of feedback amplifier. Here we have two signals. One is going to be the input signal and another one is going to be the part of output which is fed back as input. So, a feedback amplifier is going to be where a part of output signal is sampled and fed back to the input of the amplifier. This feedback amplifier is going to be of two types where positive feedback and negative feedback. This positive feedback is going to be always in phase. That is, when two signals are in same phase, it is going to be classified as positive feedback. And when the two signals are going to be out of phase, it is classified as negative feedback. The positive feedbacks are applied in oscillators and negative feedback are applied in amplifiers. Now, let us discuss about the block diagram of the feedback amplifier. First, we have the signal source. Then we have the comparison or it is also called a summing or mixer network. In between, we have the amplifier. The first where the input gets sampled is here, and this is called the sampling network. And it goes to the feedback network, and at last it goes to the mixer network. The load is going to be at the end. Generally, we have two types of sampling the network. The first one is going to be called as the voltage or node sampling, and the second one is going to be the current or loop sampling. When the input is going to be connected with the output voltage in shunt manner, then it is called as voltage or node sampling. And the same here, when the output current is going to be sampled by connecting the feedback network in series manner, then it is called as current or loop sampling. This feedback network consists of many components like resistors, capacitors, and inductors. Hence, it is going to be most of resistive configuration. This output is going to be the reduced portion fed back to the input signal, where here this beta is going to be called as the feedback factor or the feedback ratio. We will discuss now about the properties of negative feedback. The first property is going to be the density of gain. Actually, the transfer gain of the amplifier is not constant and stable as it depends upon many factors. Hence, when we are going to reduce the gain variations by introducing the negative feedback concept. And the second property is going to be the bandwidth improvement. We can actually extend the bandwidth in large amplification factor. The third property is going to be the reduction in noise, or it may also be called as noise sensitivity, which actually increases the original output by reducing the noise. And the last property is going to be the reduction in nonlinear distortion.